Have you ever experienced a powerful storm on Earth? Winds blowing at hundreds of kilometers per hour, roofs flying off, trees uprooted. But all of that is nothing compared to the storms happening every day on the sun. This isn't just wind and rain, it's magnetic chaos, with energy strong enough to wipe out entire planets. Welcome to the violent world of solar storms, where the sun unleashes its most terrifying power. What is a solar storm? When we think of storms, we imagine clouds, rain, and wind. But on the sun, a storm is something entirely different. A sudden explosion of magnetic energy stored in the solar atmosphere, often linked with sunspots. These eruptions are known as solar flares or coronal mass ejections, CMEs, some of the most powerful explosions in our solar system. The science behind it. Solar storms originate from sunspots, areas where the sun's magnetic field becomes tangled. As the magnetic field lines twist and snap like stretched rubber bands, they release enormous amounts of energy. This energy can be equivalent to billions of atomic bombs detonating at once. Types of events. Solar flare, a sudden flash of increased brightness on the sun, releasing X-rays and high-energy particles. Coronal mass ejection, CME, a massive burst of solar wind and magnetic fields rising above the solar corona or being released into space. Solar cycle. Solar storms follow an 11-year cycle, peaking around the solar maximum. We're currently approaching the peak of solar cycle 25, meaning more frequent and intense storms are expected. Types of solar storms and their power. Not all solar storms are created equal. Some are barely noticeable, while others could knock out satellites and cause global blackouts. Scientists classify them based on their strength, and the strongest ones are truly terrifying. Classification by X-ray intensity, Class A and B, very weak, almost undetectable. Class C, moderate, detectable by instruments, rarely affect Earth. Class M, medium strong, can cause radio blackouts and auroras at high latitudes. Class X, extremely powerful, capable of damaging satellites, disrupting GPS, and causing widespread power outages. Each class is 10 times stronger than the one before. An X10 is 100x stronger than an M1 and 1000x stronger than a C1. Famous solar storms that changed history. Carrington Event, 1859. Estimated strength, X45 plus caused auroras visible near the equator. Knocked out telegraph systems worldwide. If it happened today, it could cause trillions of dollars in damage to satellites and power grids. Swedish power grid failure, 2003. Strength, X45 disrupted GPS navigation and caused regional power failures. Highlighted how vulnerable modern infrastructure is to solar activity. SpaceX Starlink incident, 2022. Strength, X2.2 triggered a geomagnetic storm that knocked 40 new Starlink satellites out of orbit before they could begin operation. How solar storms affect Earth. Even though the sun is 150 million kilometers away, solar storms can still reach Earth, especially when coronal mass ejections, CMEs, launch billions of tons of plasma toward us at millions of kilometers per hour. How does it reach us? After a CME erupts, it takes 1 to 3 days for the cloud of charged particles to reach Earth. Once it hits our planet's magnetic field, it creates a geomagnetic storm, a temporary disturbance in the magnetosphere. Beautiful consequences. Auroras. One of the most stunning effects is the aurora borealis, northern lights, and aurora australis, southern lights. Charged particles spiral along Earth's magnetic field lines and collide with gas molecules, creating glowing light displays in the sky. Dangerous effects, GPS errors. Geomagnetic storms can disrupt satellite signals. Even a small error in timing can throw off GPS by several meters, dangerous for aviation and shipping. Satellite damage. Satellites exposed to high-energy particles can experience computer glitches, data loss, or even total failure. Power grid failures. Strong storms generate geomagnetically induced currents, GICs, electric currents that flow through power lines. In 1989, a solar storm caused a province-wide blackout in Quebec, leaving millions How do scientists monitor solar storms? Thankfully, scientists don't wait for solar storms to hit before taking action. They use advanced tools to monitor the sun 24/7, giving us early warnings so we can prepare. Key observatories: SDO, Solar Dynamics. Observatory, NASA, captures high-resolution images of the sun every 12 seconds. Tracks solar flares, sunspots, and magnetic activity. SOHO, Solar and Heliospheric Observatory, NASA, ESA, monitors the outer atmosphere of the sun. Helps detect CMEs heading toward Earth stereo. Solar Terrestrial Relations, Observatory. 2. Spacecraft observe the sun from different angles. Allows scientists to track the direction and speed of solar eruptions. Early warning systems. NOAA and NASA issue space weather forecasts to warn of incoming storms. Airlines reroute flights over polar regions to avoid radiation bursts. Power companies prepare for potential surges in the grid. Satellite operators switch to safe mode or shield sensitive electronics. AI and machine learning. New AI models help predict solar storms earlier using historical data and real-time observations. Deep learning algorithms are being trained to identify early signs of solar flares and CMEs. The sun is not just a source of light and heat. It's a dynamic, unpredictable star that can send deadly storms across space. While we can't stop these cosmic events, we can study them, understand them, and protect ourselves from their worst effects. What would happen if a Carrington-level storm hit today? Or what if humans had to build artificial magnetic shields to protect future colonies on Mars? Let us know in the comments. If you want to uncover more secrets of the universe, don't forget to subscribe to Universe Vault Project and hit the bell so you never miss a new episode.